Today we're talking about inverse trig functions. The first thing I want to talk about is the notation. If you see arc cosine, that's the same as cosine to the -1, which is the same thing as inverse cosine. So all of these mean inverse cosine, all of these mean inverse sine, all of these mean inverse tangent. So be prepared to see the different types of notation. But notice over here that these operations here are not the same as these operations here, right? So cosine to the -1 is not the same as cosine and so forth, right? Which leads me to the next point. These are all operations, just like these. Everybody here is an operation, right? But they're not numbers, okay? These are not numbers. These are not numbers, right? They're operations, and these are opposite operations. And these are going to be used to find the unknown acute angle in a right triangle given two of the sides in that triangle, right? So acute means less than 90, and again, it's got to be a right triangle, right? And they would have to give you two of those sides, right? So hopefully you're familiar with SOHCAHTOA. If you're not, I recommend you watch my video on that. Otherwise, here it is again. We have a right triangle, angle A, angle B, angle C, side A, side B, side C. So SO stands for sine of the angle equals the opposite side over the hypotenuse. So sine of angle A is equal to the opposite side, A, over the hypotenuse, side C. And then basically the same thing here, except it's with cosine and tangent with different sides, right? But in these situations, you're not solving for the angle. Remember, these are angles here, these are sides here. So with these equations, you'd be solving for side A or side C, side B or side C, side A or side B. You wouldn't be solving for this angle here, right? So that's how you use sine, cosine, and tangent normally, right? So how do we use the inverse sine, inverse cosine, and inverse tangent? We got the same triangle here. This is the same ratio as before. But now, in this type of problem, they're going to give you these two sides, right? So they give you side A and side C, they would expect you to solve for the angle here, right? Back here, they would give you an angle in one of these sides. So let's say they give you angle A and side C, they would expect you to solve for side A, right? Or they give you angle A, they give you side A, they would expect you to solve for side C, right? And then same thing with these guys, right? But over here, they give you the two sides, they don't give you this angle, they expect you to find this angle. So we have to isolate this just like any other equation. This is the unknown variable, angle A. We have to get rid of the sign. So most students would try to divide the sign over. Why is that wrong? Because sign is not a number. What is it? It's an operation. Don't treat operations like numbers because they're not numbers, right? Here's a good analogy. If we have the equation x plus 2 equals 5, we're trying to isolate x. What's the opposite of addition? Subtraction. So to get rid of this plus 2, we would subtract 2 from both sides, right? Because subtraction is the opposite of addition. So here, to get rid of the operation sine, what's the opposite operation of sine? Of course, it's inverse sine, right? But again, just like in this example over here, we got to do it to both sides, right? So I have to take the inverse sine of the left side, and I got to take the inverse sine of the right side. Because these two are opposite operations, they essentially cancel each other out, just like this plus and minus would cancel each other out, right? So on the left side, we'd be left with what? Just angle A, right? So we have angle A equals, but again, if you take the inverse sine of the left side, you need to take the inverse sine of the right side. So this is what it would look like. And note that this inverse sine is on the left side of this ratio of sides. So remember, this lowercase a and this lowercase c, these are two sides, so we call this a ratio of sides. We're taking the inverse sine of this ratio of sides. Don't put the inverse sine over here. That's wrong. You got to take the inverse sine of this ratio of sides, okay? So here, we successfully isolated angle A. So you would basically punch this into the calculator. So the inverse sine of whatever this side is divided by that side. In your calculator, you usually have to push the second or shift button before you push the button for inverse sine, inverse cosine, inverse tangent. And we will now do kind of a concrete example. So here's a triangle, but here we're given the two sides. The leg is 1, the hypotenuse is 2. And let's say we're trying to find angle A. So the question is, are we going to use sine, cosine, or tangent here? Well, side B is the adjacent side to angle A. C is a hypotenuse because it's opposite the right angle. So we're going to end up using cosine cosine of angle A equals side B over side C because it's adjacent side over hypotenuse side, right? Adjacent side over hypotenuse. But again, we're trying to find the angle, not the side. So we need to get rid of the cosine. So how do we get rid of the cosine? We're going to take the inverse cosine of both sides. So on the left side, these two operations cancel out. So we're left with A equals inverse cosine of side B over side C. Now, of course, you're trying to solve for the angle, so obviously we can plug in 1 for B and then 2 for C. So you would ultimately get A equals inverse cosine. Okay, let's see. Inverse cosine of 1 over 2, and you punch that into the calculator. You're going to get, I believe that's 60 degrees, right? But make sure you're in degrees mode if the question asks for degrees. Make sure you're in radian mode if the question asks for radians. And if you have a fancy calculator, it'll actually give you pi over 3. So feel lucky if that's happened to you. Yes, so that is an example. And just to clarify, remember, cosine to the -1 is the same as arc cosine. So if I wrote angle A equals arc cosine of 1 divided by 2, that would mean the same as what we wrote here. Okay, so this statement right here is the same thing as this statement right here, and you would get the same answer, 60 degrees or pi over 3 radians. Okay, so hopefully you understood that. If it made sense, please like my video, subscribe to my channel, and thank you very much for watching.